Hello everyone, greetings of the day. In the last session, we have covered the various concepts of electrical charge, electric current, voltage and resistances. We have also gone through the color identification of the resistances along with all the units and their basic concepts. In this particular session, we would be going through the connecting resistors in series and parallel circuits. As you can see, we can connect the resistances in three manners, either series, parallel or series parallel. Now let us understand what is a series circuits. Series circuits, as denoted in figure A, that it provides a single path to the current when we apply a voltage in the closed circuit, whereas in parallel circuit it will provide multiple paths for the current. It may be two or more path to the current value. And in series parallel, it is a combination of series as well as the parallel circuit. So we are having the resistances connection in series as well as the parallel one. Right. So let's start with the detailed understanding of connecting resistors in series. When we are connecting the resistance in series, first of all, as the definition implies, it will provide only one path to the current in a electrical circuit. Second important point to be considered is the current will remain same across all the resistances in a series circuit, whereas the voltage will get divided up. So, in series circuit, current is same and voltage is divided among all the resistances. This voltage division is particularly depending upon the value of resistance, how much resistance is series circuit. In series circuit, the total resistance would be the summation of all the resistance in the circuit. If we are having two resistances R1 and R2 in a given circuit, then the total equivalent resistance would be R equivalent is equals to R1 plus R2. Next, we are moving towards connecting resistance in parallel. How we can connect the resistance in parallel? Let us assume that these are the two hands, two resistances, right? So when we are considering two resistances, then when one terminal of one resistance is connected to one terminal of second resistance and second terminal of resistance 1 is connected to second terminal of resistance 2. So in this particular manner, when the resistances are connected, so we will say that these resistances are connected in parallel combination. In this particular manner, the voltage remains same across all the resistances connected in parallel, whereas current will get divided. The magnitude of current divided across each resistance will be depending upon its magnitude. In parallel circuits, the equivalent resistance is equals to the sum of inverse of individual resistances. For example, if R1 and R2 are connected in parallel, then the equivalent resistance would be equals to 1 upon R equivalent is equals to 1 upon R1 plus 1 upon R2. In series parallel circuit, we will be having the combination of both, that is series connection as well as the parallel connection. In the given figure, you can see the connections of series. The two resistances are connected in series connection. Parallel, that is R3 and R4 are connected in parallel combination. Whereas in the parallel and the series combination, that is represented by the third combination, so we are having the parallel combination of R3 and R4 in series with the R5th resistor. This was the concept of series parallel circuits. This was the concept of series parallel connections of the resistors. Now further we are going to study the concept of power. What is power? The instantaneous rate at which work is done, or we can say the rate at which energy is being dissipated in the electrical circuit, is known as the electrical power. The unit of electrical power is watts, and for DC we can say that power is equals to voltage multiplied by current. When we are representing the voltage, this is represented by capital E multiplied by I, that is current across the. Next is the inductance. The next topic would be the inductance. Inductance is the capacity of a material to oppose the change of flow. Generally, inductance is measured in Henry, and considering the size of the inductance, generally the units are millihenry. So, how you will be define a 1 Henry? It is the amount of inductance required to induce an EMF of 1 volt when the current in the conductor changes at the rate of 1 ampere per second. So, when we are talking about the voltage across the inductance, we can write as voltage is equals to L di by dt, that is inductance represented by L, di by dt represents rate of change of current with respect to time. Next is the capacitance. Capacitance is also a property of a material, but it is the capacity to store energy in the form of electrical charge. Both elements, that is capacitance as well as inductance, are energy storing elements, and the unit of capacitance is the farad. Farad can store 1 coulomb of charge at 1 volt. The symbol of the capacitance is represented by two parallel plates or with positive sign representing the polarized capacitors. If the capacitor is a non-polarized one, then it will have no sign. The image also shows you various types of capacitors used in the electrical circuit. So, concerning this particular session, we covered the series parallel connection of resistances, electrical power, electrical resistance. In this particular session, we covered the connection of resistance in series and parallel connections, electrical power, electrical inductance, and capacitances along with their units. So, in the last two sessions, we have covered the basic concepts of electrical charge, electrical current, voltage, power, conductance, resistance, inductance, and capacitance, along with series and parallel connection of the resistances. I hope you have gone through this particular videos in detail and also reflect upon after watching these sessions by going through the question and answers that are given at the end of your presentations. Thank you very much.